Okay, in this question, we've got question 5. It says figure 4 represents a network of power cables that have to be inspected. The number on each arc represents the length in kilometers of that cable. A route of minimum length that traverses each cable at least once and starts and finishes at A needs to be found. We are told in the picture that the weight of the total network is 181. It says use the route inspection algorithm to find the arcs that will need to be traversed twice. So you must find and identify those. You must make your working clear. Okay, so we want to make this an Eulerian graph so that all the nodes are even so that we can start and finish A. So the first thing to do is, this is the picture they give you in the answer booklet. Firstly, list all the nodes. So for part A, list everything so you know, so list the node and the order. So we've got A, B, C, D, E, F, G and H. Now this is order 3, so I'm going to write 3 here, which is odd. B is 1, 2, 3, 4, so I'm going to write it in blue. C is 1, 2, I'm going to write it in blue. D is 1, 2, 3, 4, so I'm going to write it in blue. E is 1 and 2, so I'm going to write it in blue. F is 1, 2, 3, 4, 5, so I'm going to write it in red because it's odd. They're the ones we're looking to find. G is 1, 2, 3, so I'm going to write that in red, and H is 1, 2, 3. Okay, so these are the odd ones. So the key idea is to identify the odds, and we're going to pair the odds up to make them even and make ourselves have an Eulerian graph. So let's all state our option. Option 1. We can either pair up A with F somehow. If A is paired with F, G must be with H. Okay, so leave yourself a gap. Option 2. Well, A could be paired with G. So A instead could be paired with G, in which case F would need to go with H. And the last option, option 3, so option 3, well, A could be paired obviously with H, which leaves F and G. So A could be paired with H, which leaves F and G. Now, there are possible pairings. They're not the routes we might double up on yet because we've got to look at the diagram to see how to get from A to F. Now, A to F is either 18 or it's 4 and 11, which is 15. Or it's 4 at 10, that's not going to be better, or 4 at 7 at 8, that's not better. So A to F is going to be best via B, so A, B. So what we're going to do is say A to F is AB and BF, AB is 4, BF is 11. Okay, how do we get from G to H? G to H, well it's either 31 or it's 17 and 15, which is 32. 31 is definitely best, so we write GH 31. And we work out our total addition here. So what would that add if we double up on AB, BF and GH? So it would be 4 add 11 add 31. It would give us a total of 46. So we would write 46 here. Okay, let's do exactly the same thing with A to G. I want to go from A to G, A to G. I can either go 33 or I could go 18 and 17, which is 35. So that seems better. However, look, there's a trick here. I could also go via B, AB to F, and then to G, okay, which would be 15 add 17, which is 32. Now, I'm sure that would catch a lot of students out there, so be very, very careful. A, B, F, G, we're going via. So it's A to B, B to F, and F to G. And we said that was 4, 11, and 17. So 4, 11, and 17. Real tricky there. Now what about F to H? F to H is either 15 or 17 and 31. It looks like 15 is the best there. So F to H is a straight 15. So let's add those up. We're going to have 4 add 11 add 17 add 15. And we're going to get ourselves 47. So the total extra here would be 47. Okay, so let's have a go at the last one. We're trying to go from A to H. How do we get from A to H in the best possible way? So we want to get from A to H here. 33 and 31, that looks massive, 64. 18 and 15, well obviously we know this is better than 18 and 15, so probably it's 4, 11 and then the 15, I would have thought, because the quickest way to F is that way. The 7 and 7, I don't think it's going to be quicker via E here. It doesn't look it. So it'd be AB, BF, and FH. So it'd be AB, BF, and FH, which is 4, 11, and FH is equal to 15. How would we get from F to G? F to G is a straight 17. That's the quickest. So F to G is a straight 17. We add those up, so we've got 4, add 11, add 15, add 17, and again we get 47. So which one are we going to choose? We're going to choose the minimum, so we're obviously going to choose this one. So write choose, and state what we're doubling up now. So therefore our answer is we repeat arcs ABBF, AB, BF, and GH. And that's what we've been asked to do in this question here. Okay, it says write down the shortest possible route inspection and give its length. So 2 things to do here. Now the length is easy. Maybe I should just state the length because that's obviously going to be a nice easy one. The length is the length of the total, which is equal to 181, plus the thing I doubled up, which is 46. So it's going to equal 181 plus 46, which is equal to 227, and what we're dealing with, miles. So that's the easy mark. Now what we've got to do is state the route. Now the route, again, is easy. It's just a bit of faffy. So what we've got to do is make sure we've doubled up our ABBF. So rub this out, draw on a picture. We've got an extra doubling up from AB and from BF, like that, and from G to H. And what we're going to do is we're going to go around this starting and ending at A. I think the question said we had to start and end at A. It did. So it's pretty easy. We've just got to write it down as you go through, otherwise you'll forget. Let's go A, G, G, H. A to G to... So we're going to write down, I'm going to write it here and then copy it down later. A, G, and then H. And then I'm going to come back to G. So I'm going to come back to G. And then I'm going to go to F and to H. So then I'm going to go to F and to H. And then I'm going to go to E to D to F. So I'm going to go E to D to F. And what am I going to do then? I'm going to go A to B. So I'm going to go A to B. So A to B. And then I'm going to go, what am I going to do here? I'm going to go C to D. So I'm going to go C to D. And then I'm going to go B to F. So B to F. And then I'm going to go to B and then to A, and we're done. So to B and then to A. And that is my route there. So it was just a case of going through the motions and writing it down as you go along. So I'm going to copy it and paste it here, and you state your route there. Okay, so let's see what's the last thing to do. Part C. Let's read this. It is now decided to start and finish the route inspection at 2 different vertices. So we're looking for what's called a semi-Eulerian graph, i.e. one where there's 2 odd nodes. They're the way you'd start and finish. The route must be able to traverse each one once. Determine the possible starting and finishing points so that the length of the route is minimized. Give reasons. Let's look, if we've laid out our work earlier here well, it's going to be easy. These 2 add to 15, by the way. These add to 32. These add to 30. Okay, now the question is, we've got to leave 2 odd. So what we're going to do is, the one we're going to double up is the one that adds least weight to the graph. Now, so we look at all our possible options. Which is the smallest out of 15, 31, 32, 15, 30, and 70? Well, either one of these 2. So I'm just going to choose this one because there's less of them. So I'm going to say that I'm going to double up FH. So for part C, I'm going to state because FH is the smallest, with 15 miles, FH to be traversed twice. Okay, so this leaves, if you look back here, what does that leave? It leaves A and G odd. Therefore, A and G left odd. Therefore, start and end at A and G. And we're done then. Okay, obviously we could have said the same thing here. We could have said make A and F retraverse A, B and BF, and that would have left G and H odd. So it doesn't matter. Either one of those would have been the right answer.